This is Jack Jackson. In this playlist, we're going to be looking at applications of derivatives. In our previous playlist, we've looked at some introduction to calculus. We've looked at some limits. We're defining this fundamental concept of calculus. Then we looked at some limit rules and working quite a bit with limits informally and then formally. And then we looked at the concept of a derivative. Of course, a derivative is a limit of a difference quotient. We did a whole playlist talking about the basic concept of derivative, approximating it, and really trying to understand what it was. Then we spent our last playlist talking about developing shortcut formulas for finding derivative functions. We also talked a little bit along the way about the relationships among the graphs of the original function, the derivative, and the second derivative. Now, in this playlist and this accompanying set of notes, we're going to examine several applications of derivatives. Now, we're actually going to begin by looking at something called L'Hopital's rule. And L'Hopital's rule is used for finding limits of functions with certain types of indeterminate forms. And it does involve a derivative in that process. Next, we're going to use Newton's method for approximating zeros of functions which are differentiable. So in other words, we're going to approximate the x-intercept of where functions cross the x-axis to find the x-coordinate of those places. And then next we're going to review the relationships among the graphs of the original functions, its first and second derivatives. And we're going to combine these ideas with our knowledge of limits, algebra, and trigonometry, and the table and graphing features of our graphing calculators and computer software to fully analyze graphs of functions, to make sure that we see all of the really interesting features of graphs. Some of that is, well, a big chunk of that last part is review of earlier material. And we'll use these skills to analyze families of functions with given parameters. So in other words, we'll have a function, and maybe it'll have some unknown constants, a, b, c, whatever, and those a, b, and c are called parameters. They're constants, they'll be treated as constants in the function, but they're unknown constants. And we'll find the derivative and the second derivative formulas in terms of those constants, and of course then find things like what are the maxima and the minima and the inflection points and the vertical asymptotes and etc. With those constants in the formulas. So we'll be analyzing entire families of functions sort of all at once. So that part of this is application of derivatives, but really more just application of derivatives to things like graphing and limits and so forth. Now, after we develop these skills a little bit more, we're going to turn our attention to using derivatives to solve real-world application problems. And these will include some of the following types. Just first of all, some basic derivative interpretation problems, applications of the local linearity property of differential functions, a class of problems called related rate applications, and then especially we're going to spend some time on optimization problems, where we try to push something as far as possible. If you think about it, many times that's what we want to do. We want to make, let's see, what do we want to do? Maybe minimize amount of area that something has for packaging, or maximize a certain volume that something will hold, or maybe we might want to minimize cost or maximize revenue, or better yet, maximize profit, or maybe maximize some area that something will contain, or possibly maybe minimize average cost. So there's lots of things that we want to take a function and push it to the extreme. And so there are a lot of real-world applications where that will happen, and we're going to look at several that arise in probably mostly the physical sciences and also in some business applications such as in economics. Now, remember, it's important to understand how the derivative shortcut rules work. And certainly we gain some useful skills in learning to apply them, but if that's the only thing we know about derivatives, then our derivative knowledge is really worth very little. In fact, it's worth less than a calculator with a computer algebra system, which can actually compute any derivative formula. In fact, really, if you have an internet connection, like you probably have it on your cell phone, okay, and we can get to some sites like maybe Wolfram Alpha or something like that on the internet, and you can actually find the derivative formula freely available for free just with any old internet connection. And so if the only thing we know about calculus is how to find derivative formulas, well, we really don't know it a lot. It's worth about $0 because that's what we can get. So if we just know a little bit about how to type in formulas and use an online software, we can find a formula for derivative. What do we need to know? As calculus students and calculus users, what we need to know is the important stuff. And what is that? That's the stuff that the calculators and the computers can't do. So that would include really understanding what the basic concept of what a derivative means, and also how it can be applied. And so ultimately what makes the concept of a derivative so powerful is its application to real-world situations in just a really wide variety of contexts. And pretty much everything we've done in these playlists and in this class so far has really been in preparation for gaining skills and applying what we have learned in real-world applications. So, not that the stuff that we haven't done isn't interesting and a useful academic exercise on its own. It certainly is, and it's important in its own right, but where we really get the power is looking at these applications. Now, in this set of notes, in this playlist that you're watching, or getting ready or watching now, starting to watch, we will see several ways of applying derivatives in application problems. And even though we're going to look at dozens of example problems and exercises, we're only going to scratch the surface of the many possible applications of derivatives. And hopefully the skills you learn here will allow you to solve problems in a wide variety of contexts, including those in whatever your chosen field of study or work is. So as usual, these notes will often present problems followed by solutions. In order to get the most out of these notes, you should read the problem, try to solve it yourself, and only then proceed to reading the provided solution. In each of the problems in this unit, be sure to give your final answer in a sentence relating to the context of the original problem. Don't just give a number answer. Be sure to include appropriate units and explain it in the context. And of course, you've already found this YouTube channel and the application of derivatives playlist, which is what you're watching now. And in our next video, we will jump into looking at L'Hopital's rule.